First half of Effects of Incendiary Bomb Attacks on Tokyo, Japan by the United States Strategic Bombing Survey. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Effects of Incendiary Bomb Attacks on Tokyo, Japan. First half by the United States Strategic Bombing Survey. Part 1. Object of Study. The primary purpose of this study was to determine why the incendiary bomb attack of 9 to 10 March 1945 by the 20th AF on the densely populated Incendiary Zone 1 of Tokyo was so highly successful. The purpose was further to appraise the fire damage to industrial establishments caused by direct hits and by exposure fires. In addition, the other major attacks on Tokyo are listed to give a more complete picture of the effort directed against the city and the damage accomplished. Part 2. Summary. 1. Tokyo, included in the world's third largest metropolitan area, had a population of more than 7 million in 1944. It was the seat of the national government and the leading city of Japan in manufacturing, commerce, communication, transportation, and amusements. The metropolitan area of Tokyo covered more than 800 square miles, the city proper more than 200 square miles, and the highly built-up portion of the city about 100 square miles. 2. Tokyo Incendiary Zone 1 was the most highly built-up portion of the city, and its 11.08 square miles had an average built-upness of more than 40%. Built-upness is a measure of the portion of an area covered by buildings. Its population density ranged from 90,000 to more than 135,000 persons a square mile, and averaged 103,000. 3. More than 95% of the buildings in Zone 1 were wooden and of typical Japanese construction. Most of these buildings had tile roofs, but some had corrugated sheet metal roofs. They were normally built in solid block fronts, separated by narrow alleys 10 to 15 feet wide. Wide streets separated these into sections of 50 to 100 blocks. The total length of fire breaks in this zone was 78 miles. 4. Home industry was highly concentrated in Zone 1, which was also surrounded on 3 sides by factory areas. Most of the people living in the zone worked either in the home industries or in the surrounding factories. 5. When it became evident that the city would be subjected to air attacks, the Japanese prepared fire breaks 120 to 300 feet wide through the densely built-up areas by raising buildings. Thousands of structures were demolished for this purpose before the end of the war. Fire equipment was increased to a total of 1,117 pieces, of which 716 were motor-driven pumpers, with capacities of 350 to 500 gallons per minute. In addition, numerous pieces of hand-operated equipment were distributed throughout the city, and an effort was made to instruct the people in their use. The normal fire department strength of 2,000 was increased to 8,100. Practically all firemen were required to go through a school of instruction. By Japanese standards, they were considered well trained, but by American standards, they were still in the recruit stage. 6. The source of water was ample for the city, but the scant distribution system was inadequate from a fire protection standpoint. More than half of all pipes were 3 or 4 inches in diameter. Pressures were generally low, varying from 0 to 25 pounds per square inch. 60% of all hydrants were one-way flush type on 4-inch or smaller mains. A few static tanks of 20,000 to 40,000 gallon capacity had been built, but they were not in sufficient number to be effective. 7. 6 attacks are considered in this report. The most important of these was the night attack of 9 to 10 March 1945, both because this attack marked the departure from high-altitude daylight bombing in formation to individual low-level night bombing, and because the efficiency of this attack was greater than any made before or since. In this attack, 9.48 square miles of the target were burned for each 1,000 tons of bombs dropped, or 1 square mile per 105 tons. A total of 15.8 square miles of the city was totally or heavily damaged in this attack. 56 square miles were totally or heavily damaged in all attacks. One other attack, that of 25 to 26 May 1945, damaged a greater area, 16.8 square miles, but the bomb tonnage dropped was twice as great. 8. The number of persons made homeless by all attacks on Tokyo totaled 2,861,857. 1,008,000 by the attack of 9 to 10 March. All attacks killed 95,972 persons, 85,793 in the attack of 9 to 10 March. Part 3. General Information. 1. The portion of Tokyo Area Team 6 which conducted this investigation consisted of the following personnel: Major G. P. Gill, Team Chief; Major T. F. Gallagher, Ordnance; Major H. V. Keepers, Fire Damage Analyst; First Lieutenant J. S. Rains, Fire Damage Analyst; Photographer's Mate Second Class J. D. DeVore, Photographer; Technician Fourth Grade M. Shimomura, Interpreter; Corporal H. L. Bourne, Draftsman. 2. The study was conducted during the periods 27 October to 1 November and 20 November to 28 November 1945. The weather during the latter period was cold and rainy, making it difficult to obtain good photographs. 3. Information for this report was obtained from the Chief of the Tokyo Fire Department, various plant managers, police, firemen, residents, and other divisions of the survey. Information from Japanese sources was usually verified by examination or by questioning several individuals on the same subject, although there seemed to be no reason why false information should be given deliberately by the Japanese. Cooperation by all concerned was excellent. The photo cover for the attack of 23 to 24 May was too poor to be used in making a good damage estimate. The figure for the damage in that attack used in this report was obtained by measuring the damage plotted on a map by the Japanese immediately following the attack. Excellent photo cover was available for the combination of this attack and the attack of 25 to 26 May. And the damage from the latter attack was taken as the difference between the combination from photo cover and the former from Japanese sources. Part 4. The Target. 1. Tokyo was part of a vast metropolitan area located along the north shore of Tokyo Bay and situated in the southeast corner of the Kanto Plain. This metropolitan area, which included Tokyo, Yokohama, Kawasaki, and numerous small suburban villages, was the third largest in the world before the air attacks began. The city of Tokyo proper was the largest city in Japan, its population of 7,238,569, 1944 census, having been as great as the 5 next largest cities of Japan combined. Tokyo was the seat of the national government, the home of the emperor and the imperial court, and the center of power and authority. It was at once the greatest industrial, communications, transportation, commercial, and amusement center of Japan. It was also considered to be preeminent in respect to universities, museums, hospitals, department stores, office buildings, and theaters. 2. The Metropolitan District of Tokyo formed an irregular oval extending some 28 miles from north to south and 57 miles from east to west, totaling 828 square miles. The 35 wards of the city proper covered only one-fourth of the metropolitan district, 213 square miles, but contained more than 90% of its population. Of the city proper, an area of 103.45 square miles was highly built up, and for this reason it was considered by the United States Air Forces as the Tokyo target area. This area consisted of Incendiary Zone 1, 11.08 square miles. Incendiary Zone 2, 57.04 square miles. Target Area 90.17-3600, 8.52 square miles. Target Area 90.17-3601, 14.85 square miles. Target Area 90.17-3602, 6.70 square miles. Target Area 90.17-3603, 5.26 square miles. Total 103.45 square miles. Figure 1 shows the location of Incendiary Zone 1. 3. The largest and best buildings in Tokyo were located east of the Imperial Palace, Photo 1, in the financial and shopping districts, Marunouchi and the Ginza. There were many multi-story, earthquake, and fire-resistive buildings, but these were interspersed with flimsy wood structures. The better residential areas extended from the palace grounds well into the northwestern and southwestern sections of the city. Although most of the streets in these sections were narrow, the built-upness was not so great as in other sections of the city, and the houses were often surrounded with walled gardens. The principal open spaces were parks totaling some 7 square miles. 4. Since the primary object of this report is concerned with Mission 40, the 9 to 10 March attack, a somewhat detailed description of Incendiary Zone 1 follows. The facts presented would have applied in general to the rest of Tokyo. A. The target area chosen for Mission 40 was Incendiary Zone 1, a highly congested, rectangular-shaped area approximately 3 miles east-west by 4 miles north-south. Figure 1. The conspicuous Imperial Palace grounds lay at the southwest corner, and the western boundary extended northward to Ueno Park, another prominent open space about 2 miles north of the palace. The boundary then curved to the east and north along the Joban Railroad to the Sumida River, thence southeast to a north-south line, the eastern boundary, which was halfway between the Sumida River and the Diversion Canal. The southern boundary extended from this line due west across the Y mouth of the Sumida River to the palace grounds. The western boundary of Zone 1 bordered on Tokyo's business center, extending north and south along the east side of the Imperial Palace grounds. Included in this area was the Ginza shopping area, with its numerous shops and fine department stores. The Marunouchi section, near the palace, contained government buildings, banking houses, newspaper plants, and insurance company buildings. The north boundary adjoined Tokyo's great arsenal area and railroad marshalling yards. The eastern boundary, extending through the center of the island made by the Sumida River and the Diversion Canal, bordered on a large industrial area of steel mills, instrument plants, foundries, spinning mills, and numerous miscellaneous industrial plants on the canals in this area. The southern boundary bordered on an area of heavy industry, including shipyards along Tokyo Bay. The nearby industrial area drew heavily on the population of Zone 1 for labor. B. Zone 1 included one of the most densely populated areas in the world, Asakusa-ku, with a population of more than 135,000 persons per square mile. The remainder of the zone had a population density of 80,000 to 135,000 persons per square mile, except for a small portion in the southeast corner where the population was somewhat less. Figure 2. Average population density was 103,000. The total number of persons living within the area was estimated at 1,100,000, or about 15% of Tokyo's population. Most of the persons made their living from the industries in and surrounding this area. C. There was probably no other residential area in the world of a comparable size which equaled the built-upness of Zone 1, which averaged 40 to 50%. This means that the roof area of the zone was 40 to 50% of the total area, including streets, small parks and rivers, and all other areas within its boundaries. Photo 2. When it is considered that the average American residential area is only about 10% built up, it can be seen that Zone 1 was highly congested. D. After the earthquake and fire of 1923, Tokyo was largely rebuilt, but many temporary wooden barracks were erected to meet the emergency. In Zone 1, a large number of these barracks had degenerated into permanent slum areas, instead of being replaced as had been originally planned. E. There were 6 important targets within Zone 1, the most important of which was the Hattori Company, peacetime manufacturers of Seikosha watches, and wartime manufacturers of fuses for artillery shells. The remaining targets were railroad yards, stations, and market areas. The heavy industrial area was just east of the eastern boundary of Zone 1 and included some 35 important targets. Shipyards, steel mills, and cable plants were along the southern boundary of Zone 1. Principal strategic products were fuses, steel and special alloys, copper wire and cable, bakelite, electric motors and allied products, textiles, guns, railroad rolling stock, and numerous small parts for aircraft and automobiles. The importance of this area to the total output of strategic war products was indicated by the special efforts made to protect the plants from possible incendiary attacks. They were surrounded by 100-foot fire breaks, and special efforts were made to train fire brigades. In some instances, the Tokyo Fire Department maintained a fire station on the premises. F. This target area of Tokyo was ideal for home industry, which was prevalent in all large Japanese cities. The feeder factories were near the workers' homes, which solved the problem of transportation of raw materials to the home and finished products back to the factory. Small machined parts and foodstuffs were the principal products. Photos 3, 4, 5. These small producers were located both in homes and in small shops formerly devoted to other uses. The number of such establishments is not available, but it is known that they were very numerous and contributed heavily to the output of the larger plants. Burned machinery of these home industries was noted throughout the area. G. Dwellings in this zone were typically Japanese. Photos 6 and 7. For the most part, there were two-story wood frame, photos 8 and 9, with 1/2 to 3/4 inch wood floors covered with straw tatami mats and with tile on mud-fill wood roofs. The ceilings were of unprotected 1/4 inch wood laths. In many cases, the first floor was used for a small store or some home industry. Small charcoal braziers, photo 10, were the only means of heating the houses. Cooking was accomplished on a similar device, usually of stone or clay, built as an integral part of the building. Most Japanese homes had no basement. Framing in the usual dwelling was approximately 4 by 4 inches for studs, with intermediate members 2 by 4 inches. Outside walls were covered by thin clapboards, or bamboo lath and low-grade mud plaster. Framing members were joined by mortise and tenon joints with very few nails or other metal parts used in the construction. Photo 7. H. The combustibility of Japanese dwellings was well illustrated by tests made in this country. 4 buildings were constructed, 2 in the typical Japanese fashion with outer walls of clapboard and with exposed windows, the combination store residence type so common in Zone 1, and the other 2 to comply with the latest Tokyo fire regulations. The latter were 2 stories high with 3/4 inch plaster on metal reinforcing, lath, and with wooden shutters on windows. The 4 structures were set on fire to determine the time necessary for their destruction. Those constructed in typical Japanese fashion burned to the ground in 12 minutes. Those constructed in accordance with Tokyo fire regulations were consumed in 32 minutes. It was estimated from unburned areas of Tokyo near Zone 1 that about 95% of the dwellings were built in typical Japanese fashion. I. There were few modern apartment buildings in Tokyo. Those inspected were usually 4 to 5-story fire and earthquake-resistive structures built after the 1923 earthquake. All were located in congested areas and were susceptible to exposure fires. None of those inspected, however, was provided with exposure protection devices such as wire glass windows and fire shutters. J. The majority of manufacturing plants were 1-story masonry or steel frame structures with wood frame or unprotected metal roof trusses. Tokyo was subject to numerous earthquakes, and the construction of multi-story earthquake-resistive buildings was prohibitive in cost. Roof covering was either corrugated iron or asbestos cement. Masonry walls were widely used in the spinning and weaving mills, instrument, electrical plants, printing plants converted to other uses, or similar industrial establishments. Steel frame structures were commonly used in foundries, steel plants, machine shops, and analogous industries. K. Throughout Zone 1, there were numerous small plants, each employing 50 persons or less. The predominant type of structure housing these industries was of wood or steel frame with a roof covering of corrugated iron or asbestos cement. Photo 11. These plants were all seriously exposed by surrounding dwellings and mercantile buildings. L. The street pattern of Tokyo followed a fairly definite plan. Individual blocks were bounded by narrow alleys, hardly more than 12 feet wide. Photo 12. Groups of blocks varying in number from 100 to 300 were bounded by wide thoroughfares or canals 100 feet in width on the average. Photo 13. Sections along the east bank of the Sumida River were more or less square in shape, while the territory west of the river was irregular in pattern and size. Due to the highly combustible structures and narrow alleys, these sections were the smallest units that could be considered as individual fire areas. It would be possible under peacetime conditions to halt the spread of fire across one of the wide streets with a well-trained and well-equipped fire department, because brands falling on tile roofs do not spread fire. The narrow alleys made it difficult to move any but the smallest pieces of fire equipment within the individual sections. Thus, the conflagration hazard from a large area incendiary bomb attack was serious. In view of the above, it is apparent that the starting of numerous fires on both sides of fire breaks and wide streets would be more than the local householders could combat and would be too numerous for the fire department personnel to handle. This, together with the highly combustible, flimsy, quick-burning construction, would defeat the efforts of the best of fire departments. M. The purpose of fire breaks is to confine fires within certain limits and provide avenues of escape for the people. These fire breaks may be blocks of fire-resistive structures forming a solid wall at right angles to the source of the fire, or open spaces of land, canals, rivers, or widened streets made by removing buildings. Tokyo, like other Japanese cities, had many transportation canals. Where they were 100 feet or more in width, these canals made excellent fire breaks. Several wide canals were located west of the Sumida River and east of the Imperial Palace. The Sumida River was the most effective fire break in Zone 1. It divided the zone almost in half from northeast to southwest. In April 1944, the Japanese government realized that the home islands might be subject to heavy air attacks and took steps to lessen the danger of fire spread by creating man-made fire breaks. From this time until the end of the war, thousands of buildings were removed or demolished for this purpose. Photo 14. From east to west, the breaks were 120 to 300 feet wide, since the prevailing winds were north-south except in summer months. A notable exception was a 300-foot break running north to south near the eastern boundary of Zone 1. With the natural barriers of canals and rivers, these fire breaks, with the assistance of an adequate fire department, would have kept a peacetime fire confined to the area of origin. The incendiary bomb attacks, however, nullified their effectiveness by starting fires on both sides of them. Statistics on fire breaks in Zone 1 are given below. Fire breaks. Total length, miles. 150 feet wide or more, 26.3. 65 to 150 feet wide, 51.7. Total, 78.0. Subjected to fire, miles. 150 feet wide or more, 20.6. 65 to 150 feet wide, 37.3. Total, 57.9. Percentage subjected to fire, 150 feet wide or more, 78.3. 65 to 150 feet wide, 72.1. Total, 74.2. Fire stopped, miles. 150 feet wide or more, 3.6. 65 to 150 feet wide, 2.3. Total, 5.9. Percentage stopped, 150 feet wide or more, 17.4. 65 to 150 feet wide, 6.1. Total, 10.1. Note: fires were considered stopped where incendiary damage existed directly on one side of a fire break only. This is therefore a minimum assessment of efficiency, because fires on both sides were often caused by bombs falling on both sides and not by fire spread. N. Fire departments in Japan were administered from the ministerial level through the Police Bureau of the Minister of Home Affairs. In Tokyo, the fire chief was appointed directly by the Minister of Home Affairs with the sanction of the Emperor. In this manner, the fire department came under the direct control of the police department, with the result that many inexperienced men from the police department were given positions in the fire department. The actual operating heads of the various units of the fire department were usually well-educated men of long experience. 1. Personnel was generally well selected with emphasis on personal fitness, but wartime drain on fire department personnel made it necessary to relax these restrictions. When it became apparent that Allied forces were approaching closer to the home islands, an intensive campaign to increase the size of the department was made. The normal strength of the Tokyo Fire Department, about 2,000, was increased to 8,100, including 2,700 active junior firemen. The ultimate goal of 12,500 was never reached, and at the time of the survey, the actual strength was 6,610 men. 2. The work periods were definitely set out in regulations, but during the closing days of the war, the manpower shortage and the numerous air raid warnings allowed few firemen to spend more than an hour or two a day away from the stations. During the war, the recruit training period was reduced to 30 days and included the same routine as the regular school, but with less time devoted to practice. All drills were under the direction of instructors especially selected for their ability. The training period compared favorably to the time devoted to that purpose in the United States, but the subjects covered were elementary from a fire protection standpoint. The severe shortage of firefighting equipment made it necessary to use dummy or immobilized equipment for training purposes. The normal company was 7 men, and it was the usual practice to declare a company out of service if less than this number was present. This was a decided disadvantage during air attacks, when it was a common occurrence for companies to lose 1 or more men during the course of an attack. 3. Tokyo was divided into 35 wards, each of which had a main fire station and 1 to 11 branch stations. Photos 15 and 16. There was a total of 42 main stations and 190 branch stations in metropolitan Tokyo. The main stations housed 2 pumpers each, and the branch stations 1. These were pieces of motor-driven equipment actually manned. There was a total of 1,117 pieces of apparatus, of which 716 were standard motor-driven pumpers. Photo 17. The remaining equipment included 11 small 500-gallon per minute fireboats, 1 undamaged ladder truck of the 4 originally provided, Photo 18, and hand-drawn units with 120-gallon per minute motor-operated fire pumps, Photo 19. Most of the pumpers were of Japanese make with a 2-stage centrifugal pump of 350 to 500-gallon per minute capacity, mounted on a commercial chassis, Photo 17. There were some pumpers of American make, but most of these were unserviceable due to lack of parts. Equipment on the pumpers included, in addition to a meager amount of minor equipment, 2 hose reels with 1,330 feet of 2 1/2-inch single jacket linen hose, Photo 20. All trucks of Japanese make were underpowered for the purpose for which they were used. They were not considered the equal of the equipment used in the average small American town. In normal operations, the pumper answering the alarm went to the source of water supply nearest the fire, which might be a hydrant or a static tank. The hose reel was removed from the truck and the line of hose laid to the fire. The hose reel was returned to the truck and another line laid. In the meantime, the truck was connected to the source of water supply. Open nozzles were used in Japan. Small stream appliances were used, reliance being placed on hand lines with 5/8 to 1-inch tips. A minimum of 4 trucks responded to alarms, with the ladder truck responding only to special calls. Numerous small hand-operated pumps, manned by junior firemen or householders of the block associations who had been trained in the rudiments of firefighting, were scattered throughout the city. Photo 21. Each dwelling was also provided with a small concrete static water tank, always kept full. Photo 22, which was to be used by the individual in combating incipient fires started by incendiary bombs. O. Tokyo drew its water supply from lakes and streams in the nearby mountains and from wells. The average yearly rainfall in the Tokyo area was 64 inches, and the streams were all permanent, so the water sources were ample. 95% of the water was pumped by electrically powered equipment. The reservoir capacity was approximately 80 million gallons, and the total daily pumping capacity was 284 million gallons. The reservoir capacity servicing Zone 1 was about 8 million gallons. 1. The distribution system consisted of water mains up to 70 inches in diameter, with cross feeders of 20 to 48 inches. The grid, however, was weak, since it was made up principally of 3 and 4-inch pipes, with about 60% of all pipes 4 inches or less in diameter. Diameter of pipe having hydrants, not risers, inches. Percentage. Number of fire hydrants, public and private. 3 inches, 6.4%, 2,158 hydrants. 4 inches, 56.8%, 19,100 hydrants. 6 inches, 19.8%, 6,670 hydrants. 8 inches, 8.1%, 2,716 hydrants. 10 inches, 4.8%, 1,630 hydrants. 12 inches, 3.2%, 1,078 hydrants. 14 inches, 0.9%, 304 hydrants. Total, 100%, 33,656 hydrants. The quantity available through such a grid system is considered inadequate for a small town. For the congested areas of Tokyo, it was hardly adequate for domestic purposes. Pressure in many districts rarely exceeded 8 pounds per square inch, and the maximum pressure noted was about 25 pounds per square inch. It was reported that pressures were so low that householders sometimes permitted house connections to remain open to secure enough water for domestic purposes. There were 33,656 fire hydrants on the distribution system, of which 60% was on mains 4 inches or smaller in size. In heavy industrial and business districts, two-way post-type hydrants were used, photos 23 and 24, but the great majority was one-way flush hydrants, photo 25. Post hydrants were not equipped with pumper connections, draft being through 2 1/2-inch hoses or from static tanks or canals. 2. Emergency static water tanks located throughout the city for use in case of failure of the water systems, varied in size from 20,000 to 40,000 gallons. Photo 26. Shallow wells and canals were available, but no definite plan had been made for their use, as indicated by the lack of platforms which would be necessary to permit fire trucks to obtain a satisfactory water supply from them. The majority of house connections were of lead, and, during the 9 to 10 March attack, 70% of those in Zone 1 melted, resulting in a great drain on the water system. In the confusion caused by the attack, no attempt was made to isolate these areas by sectional control valves. P. A fairly well-planned air raid warning system was in effect, which was arranged and operated by the Japanese Eastern Army Headquarters in Tokyo. Radar installations on outlying island posts and at strategic mainland coastal points, Navy picket boats equipped with radar and radio, supplemented by civilian defense and military observation posts, supplied the Army headquarters with information regarding impending attacks. At the discretion of Army headquarters, telephone warnings were sent to the Metropolitan Police Board and important munitions plants. The decision as to what signals should be sounded and at what time rested with the commander of the Army Operations Room, from which all municipal sirens in Tokyo could be operated. It was customary to withhold giving the air raid alert until 30 minutes before the expected attack, and the alarm indicating the imminence of attack was to be given 15 minutes prior to the expected arrival of enemy planes. It is considered that the Tokyo air raid warning system functioned efficiently, and although considerable damage was suffered by the siren system during raids, alternate methods of control which had been provided permitted the system to furnish satisfactory service. Q. Shelters for the general public were meager or lacking entirely. Photos 12, 27, and 28. Many of those in Zone 1 were built in the sidewalks and consisted of little more than shallow trenches with bamboo or light wood roofs covered with a few inches of earth. These shelters were so close to buildings that they were worthless and were not used to any great extent. R. The fire susceptibility of Zone 1 was probably greater than that of any other similar area in the world. Fire susceptibility is a loose indication of the probability of an area burning to a specified extent or degree. All the factors discussed under the target had an influence on the measure of the fire susceptibility. To give a better understanding of how some of these factors were concerned, a few of them will be considered below. 1. Assuming that an incendiary has been placed on a target, the entire target is more likely to burn, i.e., its fire susceptibility is greater, if any set of conditions exists which will tend to utilize the heat given off by the portion of the target which is burning to ignite portions not directly affected by the incendiary. The high built-upness of Zone 1 increased its fire vulnerability, since the buildings were close together or adjoining, and the heat given off by those already burning ignited some of those not directly hit by bombs. 2. A high wind was blowing during the attack, and this also temporarily increased the fire susceptibility to a very great extent, because it blew the heat and flame from the buildings already burning against those not hit by bombs, instead of allowing the heat to arise almost vertically as would have normally been the case. 3. The vulnerability of the zone was also increased by lack of adequate water pressure for firefighting, insufficient fire breaks, the high combustibility of the buildings and their contents, and the lack of initiative on the part of the fire department. End of first half of Effects of Incendiary Bomb Attacks on Tokyo, Japan, by the United States Strategic Bombing Survey.